Hello, algebra class. Welcome to lesson 5.4, fractional equations, beginning on page 114 of our textbook and going through page 117. The vocabulary we need to know for this lesson is the expression itself, fractional equation. Basically, the official explanation is an equation that contains a variable in the denominator of one or more of its fractional expressions. So basically, in this fractional expression, we have x in the denominator, as we do in this fraction as well as this. This fraction is going to equal the whole number 2, which, if you remember, 2 written as a fraction always has 1 in the denominator. And here we have equivalent fractions again. So basically we're working towards a situation where we have equivalent fractions because it works out nice and tidy to decide what x may be in an either or situation. Another thing to remember is recall that division by 0 is always undefined. So for example, you can never have a fraction with a denominator of 0. It's just undefined because you can't have 2 parts of nothing. Okay, so that we just say that's undefined. So going on, try it, number 8 on page 115. We have equivalent fractions set up within our fractional expressions, but basically that's just equivalent fractions where we do the cross multiplying. Important, write down these steps. The first step, and this is key to getting it set up correctly, you multiply both sides by their common denominator. In this case, the common denominator would be 2x plus 5 times x plus 4. So you're doing your crosses. If you do your crosses, you actually eliminate the denominators. They just disappear, because if you put them both there, you're going to get rid of the common ones. So it's really a neat thing to realize that the common denominator is this. So if you just do your crosses, you have no denominator left. Therefore, 3x minus 1 times the cross, x plus 4, is equivalent to x minus 3 times its cross, 2x plus 5. And you have nothing left on the bottom, which is key. You want to get rid of that. At this point, you're going to distribute the 3x to the x plus 4 and the negative 1 to the x plus 4 on this side, and you're going to do that same distributing process on this side. So when I do that, I end up with 3x squared plus 12x minus x minus 4. On this side, I end up with 2x squared plus 5x minus 6x minus 15. I now combine like terms, which on each side would be the x's. I have 3x squared plus 11x minus 4 equals 2x squared minus x minus 15. Now I'm going to bring this all over to the other side, so I'm working to an equals 0 part here. So I bring that 2x squared becomes negative 2x squared, so I'm left with x squared. I add an x, I have 12x. I add a 15 to a negative 4, so I have a positive 11. So now I'm left with x squared plus 12x plus 11 equals 0. At this point, and I don't do it on my paper, but I do the cross factorization of this, and I end up with x plus 1 times x plus 11 equals 0. Now I work each to 0. So it's x plus 1 is 0, x plus 11 is 0, therefore x is negative 1 or negative 1 or negative 11. And those would be my choices for answers in this particular fractional expression. So moving on to try it 19, the top of page 116. Let's get this lined up. The only difference between what I just did in 8 and what I'm going to do in 9 is I actually have to add my two fractional expressions first and then work it to equaling 2 over 1, which is the equivalent fractions. But to do this, remember, I just use my common denominators, x times x minus 2. I do my crosses in this situation, so this becomes x plus 2 times x minus 2, and this becomes x times 1, which is simply x. I distribute my x to the x minus 2 and my positive 2 to the x minus 2, end up with x squared minus 2x plus 2x minus 4 plus that extra x. So that's what's up here. At the same time, I'm doing my cross multiplications to get rid of those denominators. Well, this whole big long thing times 1 just stays this big whole long thing. And on the other side, 2 times all of this becomes 2x times x minus 2. Because I would just write x times x minus 2 next to the 2, which is 2x. Now I'm combining my x's here, which these eliminate, but I'm left with that extra x. So I have x squared plus x minus 4, and I distribute my 2x to each of those parts of x minus 2. So I have 2x squared minus 4x on this side. Now I'm working towards 0, so I bring these over. I'm left with negative x squared plus 5x minus 4 equals 0. This is a perfect situation to realign these. You need to realign them because I need to do that cross factorization. In order to do that cross factorization, this must be positive. So I just flip my signs, because by multiplying all this by a negative 1 and this by a negative 1, 0 just stays 0. So I'm not messing up what I have to do. So I just flip my signs, and now I have x squared minus 5x plus 4. I do my crosses. When I do my crosses, I end up with x minus 4 times x minus 1. When I say crosses in this situation, I mean cross factorization. And of course, each part of this is going to equal 0, so x minus 4 equals 0 is 4, x minus 1 equals 0 is 1. So my answer in this case is either 4 or 1. Continuing on to number 10, try at 10. The next layer in all of this is applying all of those steps and what we've learned in previous lessons to story problems. So let's read the story problem, try it number 10 at the top of 117, which says, Mrs. Ford spent $300 to buy some premium tea leaves. If the price of the tea leaves had been reduced by $50 per kilogram, she could have bought 0.5 kilograms more. Find the original price per kilogram of the tea leaves. The wonky setup in this problem is that 0.5 kilograms more. To understand this correctly, since we're working in fractional equations, fractional expressions, we want to change that 0.5 into half, a half a kilogram more. It just works out better. So, keeping all this in mind, here is how you think through that setup. X is the price per kilogram of premium tea leaves, because that's what they want us to find. So I take the total price that she spent, $300, and divide it by that price per kilogram, remembering that if I bought a half a kilogram more, I would end up with that price over the price per kilogram minus $50. It would have been reduced by $50 if I had bought a half a kilogram more. So that is the nuts and bolts of it. So at this point, what I'm going to do is I'm going to add these with common denominators, 2x. I do my crosses. So this becomes 600 and this becomes x. And of course, nothing happens over here. Now what I need to do is get rid of my denominators. So I take that 600 plus x times x minus 50, and I take 300 times that 2x. I chose to put the 2x in front of the 300 just because it lines up nicer that way. Now I do the distributing on this side, so I end up with 600x minus 30,000 plus x squared minus 50x. So everything's out of whack over here, but we'll get there. And then on this side, I simply have 600x. So now getting things realigned and combined, I'm going to start off with my positive x squared. I combine my x's next, which leaves me with positive 550x. And that's just still negative 30,000 equals 600x. Now I'm going to work to 0, so I'm going to bring this x over here. So basically when I bring that x over here, I end up with, I think that's a mistake. Yep. It is. It should be a negative 150. Okay, so x squared minus 150x minus 30,000. Funny, I have it here, but not there. So anyway, then I do the cross factorization, and I end up with x minus 200 times x plus 150 equals 0. I work each side to 0, so x minus 200 becomes x equals 200, and x plus 150 means x equals 150, which basically means I reject this because I can't have a negative amount of money. So my answer is $200 per kilogram. That's not 150, it's just plain old 50. What am I thinking? There we go. Negative 50x, which has nothing to do with this. But now it's right. Now it's right. Sorry about that. Okay. How it all, yeah, I worked it out correctly from that point. I'm just not sure what happened there. Okay. Must have been tired when I did that one. Okay, going on. Last problem, number 11. Here we go. Number 11. So we have another story problem in Triad 11. It says, a cyclist cycles at a constant speed from P to Q, a distance 60 kilometers apart. He finds that if he increases his speed by 3 kilometers per hour, he would take 40 minutes less. Find his speed. Okay. So we're going to let x be his speed. We start off with 60 kilometers divided by his speed minus 60 kilometers over x plus 3 kilometers, an extra 3 kilometers per hour. So we're going to find the difference between the two, and that would mean it would take him 40 minutes less. So it would be 40 minutes over 60 minutes. So now we'll find his speed. Now we'll find his speed. So we're doing this in per hour in 40 minutes. There we go. Somehow that just doesn't sound right. 40 minutes less. That sounds like it should be 20 over 60. Let me check my book. Let me check my book really quick. Maybe I can set up incorrectly. Oh yeah, you're getting into some tough stuff here. Tough stuff. Yep, that's right. 40 over 60. I was thinking something wonky. It's right, 40 over 60. Okay. Yep, just pays the double check. Alrighty, so now I've got the setup correct. Again, because I'm subtracting, I have my common denominators, x times x plus 3, and do my crosses. So 60 times x plus 3 and 60x minus 60x equals 40 over 60. Now I'm going to eliminate my denominators eventually, but first I'm going to distribute the 60 to the x plus 3. So I have 60x plus 180 minus 60x over that denominator, x times x plus 3 equals 40 over 60. I do my combining. Notice the combining just eliminates the x. I'm left with 180 over x times x plus 3 equals 40 over 60. Notice this hasn't changed yet. Now I'm going to eliminate my denominators by doing the cross multiplication. So I have 180 times the 60 equals 40x times x plus 3. I do the multiplication, I end up with 10,800 equals, and on this side I need to distribute, so it's 40x squared plus 120x. Now I'm going to work towards 0, which just means bringing all this stuff over because there's nothing really to combine. So I have a negative 40x squared minus 120x plus 10,800 equals 0. I realign this to get rid of the negative at this point because multiplying by -1 all the way through, even the 0, just doesn't change my setup that I need, except I get the proper signs. So I just flip my signs to 40x squared plus 120x plus 10,800. I divide and reduce all of this by 40. These are all divisible by 40. So I'm taking the 40 out. I'm dividing through by 40. I'm left with x squared plus 3x minus 270 equals 0. I do my cross factorization with the t. I'm left with x plus 18 times x minus 15 equals 0. Therefore, x is going to equal negative 18, and here x is going to equal 15. I reject this because I can't have negative kilometers per hour. Therefore, my answer is 15 kilometers per hour. I think the hardest part of this problem was the wording. He finds if he increases his speed, he would take 40 minutes less. They meant it would only take him 40 minutes, which would be less than an hour, because this is how they set it up in the book. But in my mind, 40 minutes less sounds like it should be 60 minus 40. But then I think, nope, it isn't, because I don't know how long it took him in the first place. So that's the whole crux of it. So you just set it up as 40 over 60. That to me was the most confusing part. It could happen to you too. So sorry if I confused you on this, but if you have any questions, you can ask me in person. I would be happy to answer. So let's see your assignment for tomorrow. I will give you your assignment. I did not bring that with me this time. I will give you your assignment in person tomorrow in class. So by the time you listen to this, you'll know what it is. Okay, thank you. Do good math. Ask me questions if you have any, and I will try to answer them.